Hello, everyone. My name is Aaron, and welcome to Mastermind's 2021 Advent of Code Challenge Series, where we'll be diving into each of the 50 puzzles that Advent of Code has to offer. This series is not designed to teach you the most efficient or elegant solutions to these problems, but rather to teach you how to dive in and break these problems down into consumable chunks and to solve these chunks using core programming fundamentals. So without further ado, let's dive into day one. So if you've stumbled upon this video, I assume you already know what Advent of Code is. But if you don't, head over to adventofcode.com. This is an Advent calendar, which is going to count up the days to Christmas. And what it does is each day, it gives you a new set of programming puzzles or programming challenges. The goal is to collect 50 stars each day. New puzzle that has 2 parts to it. You get a star for completing each one. So that's our goal. Our goal is to collect all 50 stars by Christmas. I am starting this much later. This is the 19th of December. And so, we won't finish by Christmas Day, most likely, but we will get through each of the problems. So, stay with me, bear with me, we'll get through it. But that's the goal. The goal is to finish them all by Christmas. Each challenge launches as the days progress. So the first challenge launches the first day. The next challenge does not open up until the second day of December. And so all of the challenges are not released yet. But again, we're going to be starting from 1 and heading all the way up to 25. So first thing we're going to do is get logged in. You do have to create an account and log in. It does authenticate through your Twitter, through your GitHub. I think there's a couple of other options as well. I'm going to log in with my GitHub. One of the reasons is because each puzzle has different input. Everyone's account has different input so that I cannot give you the answer to the problem. I can give you the software solution to the problem, but you still have to run your input through that. Everyone's answers are going to be different, which is pretty cool. So I'm going to log in. Again, I'm going to use GitHub. You can use whatever you'd like, Google, Twitter, Reddit. But I'm going to do GitHub. And I've already gone through that process to authorize it. There is a connection that needs to be made. So there might be a few more clicks for you if this is your first time doing it. But once you do, this is the page that you will be greeted with. This is the Advent calendar page. And so we have days 1 through 25, pretty simple. And you can see here, today's the 19th and the challenge for the 20th will open up in 1 hour and 44 minutes. So maybe, hopefully we'll be done with this video when that opens and we can check it out. But we're gonna start obviously with number 1. I have not completed, I haven't pushed any of these problems here. Challenge number 1 is actually the only challenge that I've seen so far. I have already seen challenge number 1, but it's the only one that I've seen so far. So I'll be going in kind of blind to the rest of them. But let's dive into it. So you just simply click on it and it will start to give you an overview. Day 1's challenge is actually going to give you a little bit more information about what this Advent of Code stuff is. It's going to create some lore. It's going to create, some background information for what we're going to be doing here. So I'm going to put on my reading voice. I'm going to read it to you nice and soft and sultry like, and we're going to start to pick out the information that we need to be able to solve this problem. So I think the whole first part down to here, is about what this really is. So let's set it all up. You're minding your own business on a ship at sea when the overboard alarm goes off. Really get into it. Burp, 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 burp. Man overboard. That's what it sounds like in my head. You rush to see if you can help. Apparently one of the elves tripped and accidentally sent the sleigh keys flying into the ocean. So doesn't sound like there's actually anyone overboard, but the keys to the sleigh are gone. They're into the ocean. The ocean is a scary place. Okay, all right, we know what the problem is now. Before you know it, you're inside a submarine. You've gone from a boat to a submarine. The submarine that the elves keep ready for situations just like this. Always stay prepared, I guess. It's covered in Christmas lights because why wouldn't it be? Because of course it is. And it even has an experimental antenna that should be able to track the keys if you can boost its signal strength high enough. Very convenient there. There's a little meter that indicates the antenna's signal strength by displaying 0 to 50 stars. All right, those are gonna be the stars that we are attempting to collect. Your instincts tell you that in order to save Christmas, you'll need to get all 50 stars by December 25th. We will not be saving Christmas because we will not get them all by December 25th, but we will get them all. Better late than never, I always say. That's the lore right there. That sets up this entire thing for you. You got to help the elves find the keys that are in the ocean, and we're going to do it on our submarine. So here's our first problem, I think. All right, I had to adjust myself in my seat to get ready. Yeah, collect all the stars. Each puzzle has 2 parts, and you'll get a star for each one. All right. As the submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby seafloor. On a small screen, the sonar sweep report, your puzzle input, appears. Each line is a measurement of the seafloor depth as the sweep looks further and further away from the submarine. A lot of information in this first part. Let me start to pull out the information that I feel is pertinent to solving this problem, because that's always what you want to do. The way that I like to start these, there's a lot of different ways. There's a lot of different ways that people like to do this. The way that I like to do this is to figure out my puzzle input. All right. Then I like to figure out the puzzle algorithm. The algo. And that's going to be, what things I need to do to actually solve it, and what the puzzle output's going to be. So pretty much all programming, this is what you're going to be doing. You're going to be taking input, you're going to be processing it a little bit, figuring something out, and you're going to be providing output. And that's going to be my original goal, to figure out what information inside of this challenge is going to be pertinent to these 3 different things. So it lets us know that on a small screen, the sonar sweep report is going to be our puzzle input. Sonar sweep report. Very, very helpful. We don't know what it looks like yet, but it's a report. Each line is a measurement of the seafloor depth as the sweep looks further and further away from the submarine. That actually is helpful. So each line of this sweep report is a measurement. Great, great, great. And when you think measurement, your mind should automatically, I think your mind should automatically be pointing to what types of data that would be, because data types are pretty important in programming. And so I'm already thinking integers, and I'm already thinking floats. I don't really know which one yet, because I don't know what our input looks like, but that's what my mind goes to. Maybe it won't be, but when I think measurements, these are the things that I think of. For example, suppose you had the following report. This is great. This is telling us, here is an example of what the report will look like. And so we look at it, 199, 200, 208, 210, 200, 207, 240. Great, we know that each of these items is a what? It's a measurement. Great, super helpful for us. And we know what it's gonna look like. There's one on each line. Very, very helpful. This report indicates that scanning outward from the submarine, the sonar sweep found depths of 199, 200, 208, 210, and so on. So they're explaining to us what this example input means. Helpful. We don't know what the units are. We don't know if it's meters. We don't know if it's feet. We don't really care at this point. Not super important, but we know that these are measurements. The first order of business is to figure out how quickly the depth increases. Just so you know what you're dealing with. You never know if the keys will get carried into deeper water by an ocean current or a fish or something. So they're telling us what we have to solve here. And so the algo to me is, the first part of the algo is going to be figure out how quickly the depth increases. All right. Okay, we don't know how to do that yet, but that's the goal we're going to do here. We know that we already have a list of depths, and so we're going to have to use that to figure out how quickly it increases. To do this, and they're telling us right up front how to do it. Count the number of times a depth measurement increases from the previous measurement. Okay, that's helpful. Count number of times our depth increases from previous depth. So that's telling us how to solve the problem here. So as we go from one depth to another, it seems like if it increases, we know that it got deeper. So a depth of 200 is greater than a depth of 199. So we know that those are deeper waters, okay? So they give us an example here. They work through the example input that they gave us, starting at 199. This is the first measurement. So, we can't count an increase here, but from 199 to 200, that is an increase in depth. We have gone deeper. So we do want to count that. So increased 200 to 208, we increase, that's 2. 208 to 210, we increase again. That's 3. 210 to 200. We're not going deeper. Our depth is decreasing now, so we do not count that. But 200 to 207, we do increase. 207 to 240, that is an increase. 240 to 269, increase. 269 to 260, that is a decrease. 260 to 263, that is an increase. That is 7 increases. And in this example, there are 7 measurements that are larger than the previous measurement. How many measurements are larger than the previous measurement? And you can see here, this is kind of in bold here. It's highlighted for you to tell you exactly what you're trying to do. And that's our output. Our output to this is how many measurements, excuse my terrible handwriting, measurements are larger than previous. Okay, so again, this is where I like to start with all of my challenges, is to figure out what the input's gonna be, to figure out what the algorithm's gonna be, how do we actually solve this problem, and to figure out what our output needs to be. I like it. Let's actually take a look. To begin, get your puzzle input. So our puzzle input, we click it, it opens up a new window here, and this is, again, my personal puzzle input. And this is a lot of input. Look how small the scrolly bar is on the right. And there's a lot of input here. I don't know how many there are here. We can find out in a second, but a lot of input here. Yeah, a lot of input here. And so there are a number of ways you can go about gathering this input to use in your code. We'll talk through some of that now. But first steps, analyze, break it down. First steps, comprehend. Okay, we got to make sure we understand what we're trying to solve. So comprehend, read it a million times if you have to, ask a million people if you have to, but comprehend the problem before you start to solve it. All right, now that we've analyzed it, let's get into writing some code. Okay, so now that we've analyzed the challenge, the puzzle, we can start to task out what needs to happen. We could start coding, which we will, but let's create some tasks first. The first thing is that we are going to need to figure out how to accept our input. This is the big one here. We know what our input is. We know how to get to our input. We've seen what it looks like, and we're gonna need to be able to accept this input in some way, and figure that out. After that, we will need to, each line is a measurement. So we'll need to be able to not only accept, after we accept it as input, we'll need to get the input into, a format that we can work with. And so, as we're starting to think about programming fundamentals, we start to think about collections and different collections we have available to us. Maybe getting each of these numbers into an array so that we can iterate through these things, getting it into a format that's iterable so that we can access each of these items in this list and do some things with them. So, I'm gonna put a little star right here and think, maybe we're gonna work with some arrays. If you're using Python, maybe you're gonna use, a list or something like that. But thinking about some type of collection to be able to work with this data. All right, and then because of what we've written in our algorithm and our output, we can begin to actually highlight some pseudocode stuff, we can start to think through some things. How quickly depth increases, count the times depth increases from the previous depth. And so, you know, when we're thinking of that, maybe say, you know, create a counter for increases. And we're checking the previous depth for the next depth. So maybe we need to do some compare prev. I spelled that completely wrong, but it's okay. We can always erase. Compare previous depth to next depth, maybe. And this order doesn't really matter. I'm just kind of taking the information that I've written up here from our analysis and figuring out some actionable things that we can do. We need to determine if depth increased. And if so, add to counter. Okay. And then we need to, you know, we need to do the output. So we need to either, you know, print or return total number of depth increases. Okay, so we don't need anything fancy to solve this. The hardest part, especially of the beginning problems, is always figuring out how to work with this puzzle input. Now, I am going to work for this challenge, probably for most of the challenges, I'm going to work with Go. One of the reasons I'm going to work with Go is because we have to be very explicit about a lot of things. There are a lot of rules here. Whenever you're dealing with a compiled, statically typed language, rules matter a little bit more. And I think that's going to be helpful in explaining the process and figuring out what's going on and keeping track of what's going on. It's completely okay if you know nothing about Go. We are going to be highlighting we're going to be breaking down and understanding exactly what we're doing. So the language doesn't really matter. And in fact, for this, probably for just this video alone, maybe I'm going to do it with Go. We'll break it down into the right pieces. We'll comment, you know, what it is that we're actually solving with a section, and then maybe we'll convert it directly over into JavaScript or Python or something, so that you can see it's not about the code itself. It is about learning how to solve this problem. So I'm going to create a file. I'm going to call this, actually, I'm going to create a directory. Yeah, I'm going to create a directory here, and I'm going to call it day1.go. Actually, I don't need to call it .go. I'm just going to call it day1 because I'm in this Advent of Code folder that I created. Now, if you've never seen my content before, you'll realize that I'm a bad typist. Just bear with me. I'm getting better every day, but I'm not a very good typist. But I'm going to move into day1, and I'm going to create our first file, and I'm going to vim day1.go. All right. And luckily, I've got some things set up. It creates a Go application for me. So the first thing we need to do is accept input. This is always the hardest part. What is the easiest way to accept some input or to get your input in the code? The easiest way, I need to delete the bells in here, but the easiest way is to paste that code, that input directly in. So you could, you know, your first choice of this, I could create a variable. I could say, I could create a variable called input here, and I could set it equal to, you know, like a template literal or a multi-line string or something, if I wanted to, and I could just copy the whole thing here, Control A, Control copy, and I could paste it just like this. And now all of my input is in here, but you can see this is annoying. This is not fun. This looks very, very bad. And now, you know, it's gonna be tough for me to like see what's happening in my program. All of my code will be at the bottom, but you know, this is kind of gross. This is perfectly acceptable to solve these things though. You could just copy it and paste it in. Now, you gotta be aware of the language you're using and how to make this work. Most languages, you cannot just paste in a string that's this long. and it has multiple lines in it. Usually you have to, again, create some type of template, create some type of, use a different kind of data to be able to do exactly that. So what we're gonna do is we're gonna learn how to read a file. And we're gonna figure out how to do this once, and we're gonna apply it to every single one of our challenges because almost always we're gonna be pulling in data this way. So we're gonna do the work once, and then we are going to use it over and over again. So I'm gonna undo that. And I have been teaching a course for a little while about JavaScript. I haven't used Go heavily a lot in a long time, and so I actually have no idea how to do this. So I'm simply going to Google this piece. But again, our goal is understanding that first, we need to know that we can accept input from a file. All programming languages can allow us to do this. And so we're gonna do that. So I'm gonna say Golang, read file line by line. So I'm gonna click that. I'm gonna type that into Google, and I'm gonna see what options we have available to us. I'm gonna take one and I'm gonna try it out. You don't need to worry about whether or not it works or not. You don't need to, be discerning and understand what you're reading. But if you're unsure about something, if you're trying to figure out what's happening, copy and paste the code and run it. Yes, that can be dangerous sometimes, but if you're going to a reputable site, copy and paste it, run it. This should be relatively safe to do. So I'm not even really going to read through this. It just seems correct. I think they meant 1.11 or maybe not, 1.1 and newer. Looks like we can use buffio.scanner to do this. So we're gonna have to import a few packages. Go is a pretty cool language where there's a lot of cool tools in the standard library. And so in this course, we are gonna be staying away from external libraries. And Go, these libraries are built right in. These are part of the standard library that it has to offer. And so you have to use these tools like this. So I'm gonna take all this code right here, and I am going to paste it in. Yeah, I'll take it and I'll paste it in. I'm actually gonna to make it easy for copying and pasting purposes, I'm gonna take all this and I'm gonna delete everything here, and I'm gonna paste in what we copied. All right, and so I can start to look through this code to figure out what's going on. I'm confident this code works. For languages like Go needs a main function to run. So this is going to be the function that runs whenever our code actually executes. So it looks like we're going to open up a file, and we're going to put our path to the file inside of here in the string here. We're going to handle if there's a problem, we're going to handle that. And it looks like it's going to save that information into scanner, and then there's going to be a for loop that's going to scan. That's going to iterate over that input, and it's going to print out each line. I think that's what it's going to do. That's me quickly reading through it. This part is not necessarily important for you to really understand yet. The goal, again, is to know that we can read a file into our program, and we can use the data that it's reading to create some type of data for us to work with. Every language, again, has this, so you can look for how to read in a file if you need to. So I'm going to test this, okay? The first thing I'm going to do is I'm going to take our input, and I'm actually going to put it into a file. So I'm going to save this. I'm going to make a file right here called input.txt. All right, and I'm going to go back. I'm going to grab my input, and I'm going to put it in here. This is a text file, and I can see it has 2,000 items in it. That is a lot of items. That's great. They give you a lot of input so that you won't go through and do this manually to get the answers, that you will use your code to do so effectively. So I have this text input file. Again, I can, if I was unsure, if I didn't have line numbers on and I want to see how many items there were in this file, I could do a WC -L on this file, and it would tell me that there are 2,000 items or 2,000 lines in this file. So 2,000 inputs. That's helpful. That's really helpful. We'll talk about why a little bit later. Actually, let's talk about that now. This gives me some information that when I'm trying to figure out if my output is correct, I know that if there are 2,000 items in this list, my answer can't be over 2,000. Like the max it can really be is 1999. If it increased every single time, the most my answer could be for this part is 1,999. And so that helps me, when I see output, when I'm testing and figuring things out, it's giving me a little bit of information that I can use to determine if I'm on the right track. So, okay, I have my input file. Let's take a look back at our Go code. So it looks like our path to our file is right here on this line. So I'm gonna put the path to our file, which I'm assuming I can use, this relative path. I'm gonna do ./input.txt. I don't know, I actually have no idea what this needs. And so I'm gonna put it in what I think, and I'm gonna run it. Maybe it just takes input.txt, but I'm gonna try ./input.txt because this is in the same directory as our input file. And I'm gonna save this, I'm gonna run it, okay? So I'm gonna do, just so you can see what's here, my day1.go and my input.txt is right here. And I'm gonna do go run day1.go. And we get a bunch of output. That is super duper helpful, okay? It's very, 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 very helpful. But let's look at our code. You might run that and you might say, oh, I'm good to go. That's super helpful. It is. Well, here's what I'm gonna do. I'm gonna take all this and I'm gonna package it up into a little function that we can use again over and over again later. I would make it so that's something we can import, but I'm just gonna make, this is our very first time doing it. We'll need to do it every single time. So I'm going to create a function here, separate it out from the main function, and I'm going to save this as another file so that we can start with this file every single time we work on a project. So I'm gonna delete all this. And I'm gonna do it above this. I'm gonna make a new function here. I'm gonna call it input parse. All right, input parse. And what input parse is, it's gonna take in, I need to take in something. I'm gonna have it take in the file, the path to the file that we need to take in. So I'm gonna take in file. The file type is gonna be a string because remember in Go we have to be very explicit about types. So it's gonna take in a file that is a string and it's gonna output something. Here's the problem. Later on in the course, we don't know exactly what our input's gonna be and what we're gonna need to output it as. But for now, because we are taking in this file, it has a bunch of measurements in it. Our output is going to be we want a collection, so an array or a slice in this case, and I'm going to make it a slice of integers. Okay, because we're going to work with numbers, I'm going to say for now I think we're going to return a slice of integers, and then we're going to paste in all of the code that we have here. All right, so it's going to take this in. Because we are going to take in the file name, we are not going to do this. We are simply going to do file. Okay, we're passing in the file name right here. So it'll open whatever file we pass into this function. Okay, so I think I've successfully stolen code off of the internet and implemented into my solution. What's helpful, well, I want to be very clear about breaking this up mentally from the actual solutioning of the problem. We're just doing what we need to do to be able to take in our input at this point. And so again, like I said, there's a number of ways to do it. We could have just pasted in our input as right into a new array or something, or right into a string at the top of the file. But that, that's a little bit gross, but it does work. It works well. So I have that function here, and I'm gonna call that function here in my main function. So I'm gonna say, I'm gonna call input parse. Actually, I'm gonna save that to a value. So we're gonna say our input, we're gonna make a variable called input, and we're gonna save it to the value of input parse, and we're gonna pass in the file name, which was, I'll do the same thing, /input.txt. Again, input.txt might just work, but I will do this. I need to do one more thing. This will actually fail. This is something that I like about Go. It'll actually fail because I'm telling Go that this function will have some output. It should pass back a slice of integers, an array of integers, basically. And so if I try to run this, it actually won't run because again, it's there's a lot of things happening here. I'm gonna go ahead. I'm gonna go back in here. Whoops. I don't know what I did there. Maybe I held shift too long, but I'm gonna return something. Right now, this is just listing out each of the items, okay? It's not actually creating any data for us. So I am actually going to create an array or a slice. This slice that's gonna return, I'm actually gonna create it in here, okay? So I'm gonna say right above this scanner, it can really go anywhere in here, but I'm gonna say var, I'm gonna put input slice, and I'm gonna set that equal to, I'm gonna, a slice of integers. I'm telling it what kind of data it's gonna be. And then when this actually runs, when we go through each of the items line by line, instead of printing them out like we were doing before, I'm actually gonna add them to this array or add them to this slice. And so the way that I'm gonna do that is I am going to, I'm gonna try to recall as much as I can without going to, without looking up some of the things, just, as a practice for myself. The way that I would do this is input slice is equal to append. I think append is the function here that we would use. And each time, so append takes in two things. It takes in the thing you want to append to, which is input slice, and the thing that you actually want to append. And so right now, scanner.text is what was already there to print out, which is, which was working. So I think that's the right thing. And I'm going to append it to input slice. This is going to be helpful. The problem is scanner.text is, likely this is a string. I don't know what type of data this is right now. I haven't put in any probing statements or anything to figure that out, but, I would be able to see that, if I appended each time to this, if I try to run this code right now, it'll likely, tell me, it gives me a lot of stuff. But probably that it can't append a string into type int. That is what I was worried about. So we actually got to do some type coercion or type casting here. So let's, before we actually do that, let's put a little note here that says a function that reads a file line by line and puts each line into an array and returns it. That's our goal here. So that it's a function that reads a file line by line and puts each line into an array and returns it. I'm gonna need to do some type conversion here, type casting, type coercion. So I'm gonna need to change this text into a number first because I wanna work with numbers. Yes, I could work with strings for a little while, but I have to do, again, some type of, I'd have to do some type inferencing and kind of convert things on the fly. I wanna be explicit here. And so what I'm gonna do is each time it hits one of these things, I'm gonna convert it. And I'm gonna convert it to, input int. I'm bad at naming things, as most people are. Input int is going to be equal to, let's go, I think I have to create a variable up here first for input int and make it a integer. And I'm gonna do input int is equal to, let's say, I think this is the package string conversion .atoi, which is like ASCII to integer, I believe, and that's how you convert it in Go. And I want to convert scanner.text, which is going to be a string, and that should convert to an integer for me. And then I want to add that integer to our array. Input int here, that feels okay. And I think my stuff is set up right. There we go. It adds string conversion there. And at the very end of this, we will want to return our, what do we call this? Input slice. Okay, this is likely going to be the most complicated thing that we do all day. I know it might be confusing, but again, this is just helping us be able to get the information out of our input file. This is going to be helpful in the long term. Okay, we're only gonna write this code one time. We're not gonna have to write it again. We might have to modify it a bit. I am going to put this into a repo if you'd like to try it with Go. But again, I'll show you how to do this in other languages as well at the end of this. But we're trying to make things as easy as possible for reusability so that we can complete all 50 of these challenges. So I'm gonna try to get this, I'm gonna pass an input.txt, and all I'm gonna do right here is I'm typing in some JavaScript. I am going to format.println input. I want to see that input is now an array. So I'm gonna save this. I hope it works. It does not work. Cannot assign OS file type string in multiple assignment, cannot use. So I got a lot of errors here. Let me see what our problem is. And again, I just took this code off of here. So I wonder, I'm passing in a string, file open. I wonder if string does not implement IO reader, missing read method. Undefined type string has no. Hold on, let us figure this out really quick. So line 13, let's check line 13 first. Actually gotta read the errors. So open, let's pass it as file, open file, which is a string. That seems right. OS file, pointer to file type string in multiple assignment. Cannot use OS file as type string in an assignment. Okay, all right, so I guess what goes in here is not actually a file. It is, or is that actually a string? Actually, I wonder if this is a keyword. What if I do something like X? All right, there we go. The word file, I think, is a keyword here. And we have an error on line 25. We need to this string conversion, ASCII to integer, actually returns two values, which is an error and the actual value itself. I'm going to throw away that error if we should receive one. And now I'm going to run this. So here is a slice of items, and we know that it's a slice because it is wrapped in these square brackets. So we did a lot to get to this point. Okay, we did a lot to get to this point. I know it's confusing, but it's okay. All right, it's completely okay. The goal is to know what we did here. What we did is we created a function that will parse our input for us, and we can use this over and over again. So what I'm going to do is I'm going to save this, and this will be the base of every single one of the challenges that we do. So I'm going to save this right now, and I'm going to copy this. I'm going to copy day1.go. I'm going to copy it back a directory, and I'm going to change the name to parse input.go. All right, and now we have this parse input.go file that we can start with every single challenge. Okay, let's go back into our day one challenge and let's actually start the actual code now that we can parse our input. Okay, our input's parsed. Let's start to actually solve this problem. So we don't need to actually print out our input. We're able to get it, and all of our input is now in this nice little variable called input, and that input is of type slice of integers. It is an array of integers. Okay, so it's a list of integers. We know that these arrays, these slices, they're iterable. We can move through them. We can iterate through them using loops. Okay, so what we're gonna do is we're gonna write a loop so that we can start to access every item in this list, because we know that we're gonna need to do that to solve our problem. So Well, let's start off with a, should we write another function for this? Parse our input. Let's write a function for this because there are two parts to this problem. Let's write a new function down here and to make it very clear what's happening. So function, I'm gonna say part one, okay? So that we know our code for part one is just in this function alone. And part one is gonna take in some inputs, okay? Which is gonna be the input that we grabbed here. So part one is gonna take in input, which is, that data is a slice of integers. And the thing that it should return is the output, okay? So how many measurements are larger than the previous measurement? And so that output is gonna be an integer, all right? So that is, we got our input, we got our output. So the first thing that we wanna do is, I think we should iterate through each item in our input, slice / array. So we want to iterate through each of those items. The way that we do that is we're going to use a for loop. Go actually only has for loops. You can use them in a number of different ways. You can pretty much solve everything with a for loop. So in a for loop, the very first thing that happens is going to be your setup. We're going to set up an incrementer that we can use to track how many times this thing is running. This only runs once. It runs at the start of the for loop. So we're gonna set a variable called I. We're gonna set it equal to 0, okay, to kind of start our loop. We're gonna set it equal to 0 because the first index, Go is a 0 index language, just like pretty much every other language that you are likely using. And we're gonna start with the first item in the list, and that has the index of 0. We're gonna run this loop. The next part is the condition in which this loop will run or not. So this loop will run for as long as the condition we're about to specify is true. We want this loop to run for as long as I is less than the length of the input array, okay? So the input array we know has 2,000 items in it. We want this to run 2,000 times. So we're going to use this I to count up how many times this loop has run. And we want it to run for, 2,000 times. So length of input is going to give us 2,000. Okay. And then the last part is we want to know, or we want to set up something that's going to happen after each iteration of the loop. Every time the loop runs, we're going to add 1 to I. So what that means is, it's going to hop into the loop. The very first time, it's going to create a variable called I. It's going to give it the value of 0. It's going to compare I to the length of input. So if the length of input we know is 2,000, it's going to say, is I less than 2,000? Yes, it is. That is a true statement. As long as the statement evaluates to true, then the loop will run. Imagine this is a big if statement. And so it'll run whatever code is in between the curly braces for the for loop, it'll run that code. Once that code executes, it will add 1 to I. This is the last thing that happens. It will add 1 to I, and then it'll start the loop over again. So I will now be 1. And so it'll say, is 1 less than 2,000? Yes, it is. It'll run our loop again. It will get done. It'll add 1 to I again. I will now be 2, and so on and so forth. So, whoops. So here is what we're going to try to do here, and maybe I'll draw it out for you as well. What we're going to do is we're going to use the index location of this array. So in an array like this, if we have, 99 and 101 and 86 and 7 and 10, each of these has an indexed location. The first item in the list, the index location is 0. This is 1. This is a 2. This is at the 3rd spot. This is at the 4th index. These lists, these arrays, these slices, they are ordered lists. So the things won't move around. They will remain in this location. And so what we can do with this for loop right now is, as we are going through it, we are increasing I. So the very first time this loop will run, I is equal to 0, okay? And so we can use that index to access this specific item. So we can say, hey, let's actually do this. Let's just simply console Sorry, this is Go. Format.println. We're gonna format.println input. And the way that you specify an index is with bracket notation. And we're gonna say at the I index. At the I index or I element. So what this is gonna do, the very first time this code runs, I will get set equal to 0. It will say, is I less than length of input? Is 0 less than 2000? Yes, it is. That means this loop will run. It'll drop down and it'll run the code inside of here. It'll print out input at I. I is 0 on the first run of this. So input I is going to equal this item here. And so it'll be, input I will be 99. So it's gonna print out 99. After that's done, this completes all the items in the loop. It will add 1 to I, okay? So now I is 2. So I goes from 0, because we called it 0, we set it up as 0 the first time. It's now 1. So is 1 less than 2000? Yes, it is. So when it gets down here, input of I is now 1. So it's gonna print out input of I. So it's gonna print out 101. Once that's done, it's gonna add 1. Now I is 2. So it's gonna say, is 2 less than 2000? Yes, it is. It's gonna print out input of 2. Input of 2 is 86. So it's gonna print out each of these numbers one by one. So I'm gonna save this and I'm gonna run it to make sure our for loop is executed correctly. And so if I were to run this right now, we get some errors that says, hey, you have a function that's not being used. And the way the functions work, functions are little bits of reusable code that only run when they're called. So I'm gonna call part 1 in our main function here, because you gotta call it, well, we gotta call it somewhere. And the main function is the only function that runs by default here. So I'm gonna call part 1. Whoa, that was a mistake. Fat finger that. I'm gonna call part 1 and I'm gonna call it with input. So we're gonna parse our input here. Once we get our input back, we're gonna pass that into the part 1 function. So this should end up running this for loop and printing out all of the information that we care about. So I'm gonna save it. And then I'm going to go run day1.go, missing return at the end of a function. Great. So I need to return a function. I need to return an integer because I told this that I was gonna return an integer. I can just remove this for now. Nope, I'm not gonna do that because I'm gonna forget to put it back and we're gonna run into another mistake. I'm gonna return 0. We don't care about the return right now because we're just kind of testing some things out. We're using some probing statements to make sure our stuff works. And so when I run this, I can see that I'm printing out each of the items. This is, there are 2,000 items. I don't want to scroll up and verify, but I can check the bottom of this list over here and see that the last item here is 7121. Same thing over here. Great. Our for loop is operating correctly. Now, how do we change up our for loop to do what we need it to do? Well, to solve this problem, we need to compare one number to another number, starting with the first one all the way up to the end. So what we can do is we can start to use the tools that we know that are available for comparisons. And so we talked about it here. We said the word greater than. Okay, we can use a conditional, so we can use an if statement here to determine whether or not a number is bigger or smaller. So I'm gonna say if, okay, the numbers that we're gonna compare, I'm gonna compare the current number that we're on. So the current number, because we're using indexes, is gonna be I. So I'm gonna say if input at I index, okay, so each loop iteration, this is going to be the number that we're on. If it is less than the next number, the way that we identify the next number is we do I plus 1. That will allow us to identify the next number. Here's how that works. Let's remove this little section here. If input of at the 0 index, if that is equal to 99, the next number next to it is at the 1 index. So that's the same thing as input of 0 plus 1. So that's the same thing we're doing here. We're using I in place of 0 because we want it to be dynamic, but same thing here. If we wanted to check the number that was 2 away, if we wanted to check 86, it would be 0 plus 2. Okay, so we could simply add to give us a new integer that will give us our new index number. Okay, so we're gonna check if I, the current index that we're on, we're gonna check if it's less than the next number. Okay, if the number on the left is less than the number on the right, that means the number on the right is greater than the number on the left. And this tells us there was an increase. Okay, so if this statement evaluates to true, there was an increase. And if there's an increase, we need to count that. So what I'm gonna do here is I'm going to create a variable called count. I'm gonna call it counter. I'll call it count. Okay, and I'm gonna make that an integer. And we're gonna use this variable to count up how many increases there were. And if this statement is true, if the depth did increase, all we need to do is add 1 to count to the count variable. So we can do that in a couple different ways. We could do count equals count plus 1. That's one way we could do it. Some languages you can also do count plus equals 1, or you can do count plus plus. All three of these things do the same thing. They add 1 to count and they save that value back into the count variable. Okay, so I'm gonna do count plus plus for readability. I like count plus plus, and we're gonna add 1 to our counter. Now, this should go through every item in the list. It should count up the number of increases, and it should, it should count up the number of increases. Now, we simply need to return, instead of returning 0, we need to actually return the count. Okay? So, we're comparing the current number to the next number. The number at the current index to the number at the index plus 1. And then we're returning that count after we count it all up. Right now, we're not gonna see the count because we aren't printing it out. So let's do a format.println. We'll do a format.println here. And let's run it. And we got an error here. Index out of range. Great error. Errors are super helpful. Another reason why I like using languages that are a little bit more strict, because they give you some good insight here. It says index out of range with length 2000. This means that we attempted to access an index that does not exist. So if there are 2,000 items in this list, okay, we have 2,000 items. If it tried to access index number 2000, it would not exist. That would be an index that is out of range. The reason being that I told you before that arrays, slices, these are 0 index. So the first item in the list is actually the number 0. It's at the number 0. This means if there are 2,000 items, the last number is actually 1,999. The last index number is 1,999, not 2,000. So we need to modify our code. This is very normal. This is something that you'll run into. Off by 1 errors or something that you'll run into a lot. And so we'll do length of input minus 1. This is always how you find the last index of an array, is the length minus 1. So I'm gonna save this. I'm gonna run it again, and I get some output, 1521. And before I go and put that input in there, let's mark up what we're doing. Let's put some comments in so that we know what we're doing. Here's that function up top. It's taking up a lot of our space, and it might be looking confusing. I would put some separation in here, but I think that Go is going to format it for me anyway. But we created a function that's going to handle part 1. The first thing that we did is we created a variable to track number of depth increases. So we created a variable that we could use to track that number. Okay. Then we created a for loop to iterate through each item in our collection. Okay. So this goes through each item in our input array. Then what we did here is we compared our current item, our current element, to next element to see if next element was bigger or was larger. And if it was, we added 1 to the count variable. All right, and then once the for loop was over, we simply returned value of count. Okay, so we got an answer here, and let's go ahead and put it in and see if it works. Remember, my puzzle input will be different from your puzzle input, so it may not work. So let's go ahead and let's submit that. And that is the correct answer. We now have 1 gold star. Very, very, very exciting. Very, very exciting there. I will push this code to a repo so you can kind of check this out and you can see how we solved part 1. Like I said, we'll do this with another language at the very end of this video so you can see how this will apply. What did we actually do? We, again, created a variable to track what we the number of depth increases. We iterated through our input array. We created an array for our input items, and we iterated through that. There are a number of ways to iterate through that input. Loops are how you do that, but there's a number of loops we could have done to make that happen. There's a couple different ways we could have went about doing that. As we were iterating through the items, we were comparing the items to see which ones were larger. And if they were larger, we were adding 1 to the variable that we were using to track this, and we simply returned it. All right, we got our first gold star. Now let's hop in and let's see what part 2 has in store for us. Okay, so now that we're continuing to part 2, I am going to see if there's new input, if there's a new algorithm, and if there's new output. We don't know what that is yet. All right, part 2. Considering every single measurement isn't as useful as you expected, there's just too much noise in the data. All right. Instead, consider sums of 3 measurement sliding window. Sums. So as soon as you see sum, I'm going to put addition here on the input side of things. So 3 measurement sliding window. We have an example here. I think I understand what they are saying from this, but if you don't, I think they go on to explain this sliding window here. Start by comparing the first and second 3 measurement windows. Okay, so we're going to compare only 2 things, but they're going to be inclusive of 3 measurements. The measurement in the first windows are marked A. So the first window is going to be 199, 200, and 208. So we're going to add those 3 things together. So we got A, so 199, 200, and 208. Their sum is 607, okay? The second window is marked B. So B, 200, 208, 210. The sum is 618. So when you add up these 3 numbers, you get 607. When you add up these 3 numbers, you get 618. The sum of the measurements in the second window is larger than the sum of the first. So this first comparison increased. All right. So it seems like we're doing the same thing, but we're combining some numbers to get a better picture of what's actually going on. Your goal now is to count the number of times the sum of measurements in this sliding window increases from the previous sum. So same thing, compare A with B, compare B with C, C with D, and so on. Stop when there aren't enough measurements left to create a new 3 measurement sum. A lot of information here, a lot to take into account. So our input is still, it seems like our input is still the same. We're still taking in this depth report where each line is a depth. So I don't think we're gonna have to change anything about parsing our input here, but it seems like either in our input, we're gonna need to sum of 3 depths, or over here in the algorithm, we're gonna need to take the sum of 3 depths. Okay, and the output's the same. Number of depth increases, but instead of individual depths, this is going to be 3 sum sliding scale comparison. But again, all we're doing is we're still essentially doing the same thing here. We just have we've got to do a little bit different in the algorithm section of this. Okay, let's see if we can figure this out. So I'm going to create a whole new function down here, and I'm going to call it part 2. So func part 2. That's going to do the same thing. It's going to take in our input, which is a slice of integers, and it's going to give us the same output. It's going to give us an integer as output, which is going to be the number of times there was an increase. And so we can actually we still need to do the same thing. So we still need to have a counter. We need to have a counter still. And so let me actually just copy. Oops, what just happened there? Oh, that was never mind. I thought it was line 19, but it was actually relative line. I forgot I had relative numbers on here. So I'm gonna yank this and I'm gonna paste it here. And so we're gonna create a variable to track number of depth increases just like before. We're also gonna create our for loop again. And so I'll write it out so that we can get some practice. For I equals 0, while I is less than length of input minus 1. I'm copying it again. Some of you are probably already seeing an issue with that, but we'll leave it there for now. So here is the same for loop for the most part, but now we need to do some things differently. We need to compare the sliding window, this sum. So I'm going to actually create 2 new variables. I'm going to create a new variable called sum1 and one called sum2, where we're going to add up these items that we can use to be able to do our comparison. I'm actually going to put them here. Sum1, which is going to be integer, var sum2 is also going to be an integer, and I'm going to set sum1 equal to, okay, this for loop's going to execute. The very first time it runs, I is going to be 0. It's going to say, is I less than length of input minus 1? Yes, it is, because the length is 2000. Minus 1 is 1999, so 0 is less than that. That's true. And so it's going to run. The way that we add up, we sum up these things, addition in Go, like many other programming languages, is simply a plus sign. So I'm going to say sum input at the first index. Okay, so we're using I to track our indexes. So we're going to use I. So on the very first run, it's going to be 0, which is the first item. And we're going to add that. What are we going to add that to? We need to add it to the next number. So the same way that we did before, I plus 1 is going to be the next number. And the next number is I plus 2. Okay. So that's going to add up the first 3 numbers. Again, let's look at our whiteboard over here. And again, imagine we have numbers like 10, 15, 25, 5, and 11. Super random. But the first time this loop runs, when I is 0, it's going to look for input at the 0 index. Great. Input at the 0 index is the first item. So it's going to say 10. So 10. So this section here, input of I on the very first run, it's gonna say 10 plus input plus 1. So input of I plus 1 is now gonna be 1. So input of 0 plus 1 is actually this item. It's gonna be plus 15, and input plus 2 is gonna be this item, so plus 25. So we are gonna get 40, 50. It's gonna equal 50. So that's how you add those three numbers together. That's the first slot. That's the first 3-digit window. How do we get the next 3-digit window? Well, when they say, from the example, what they're doing is they're comparing the sum of 10, 15, 25, 35, 11, 12, whatever. They're comparing these three, the sum of these three, to the sum of these three. Okay, so they're comparing 0, 1, and 2 to the sum of 1, 2, and 3. So because we know what those indexes are, we can actually just specify those here. And so we're gonna say input of I plus 1 plus the input of I plus 2 plus the input of I plus 3. All right, so that's gonna give us 2 sums. And then we can do exactly what we did before. We can do our comparison and say, if sum 1 is less than sum 2, then we know if sum 1 is less than sum 2, we know that sum 2 is greater than sum 1. And we know that an increase did happen. And if it did, we can do counter plus plus. And whoops, I deleted something. There we go. All right, so we can do counter plus plus, and at the very end we can return count. And let's go ahead and let's call this and see if it worked. And then if it did work, we can go through it. So we can take this where we're calling part 1, and we can change this to part 2 with the same exact input. And now I'm gonna run it. Undefined counter. Okay, so I probably typed in something wrong here. Oh yeah, I'm adding 1 to counter instead of just count. Index out of range. Remember, I kind of alluded to this when we were writing our for loop, that there might be a problem with what we were doing. There's a line here. This says, stop when there aren't enough measurements left to create a new 3-measurement sum. All right, here's a problem that we are running into, and this is why, again, languages like this are like Go are good. If you're using JavaScript, I actually don't think you'll run into a problem. I think it'll allow you to do this, which is, problematic, but you got to understand what's happening here. If we have our array, 1, 2, 3, 4, 5. Let's say our loop runs and it's on the 4th iteration. This is on the 5th. It's on the, let's say it's on the 5th iteration, the 4th iteration. So it's already, so I was 0, then I was 1, then I was 2. Now let's say I is 3 now. What happens is, if I is currently 3, it'll attempt to add together input of I, which is 4. It'll attempt to access input of I plus 1, which will actually give us 5, and then it'll attempt to access input of I plus 2. And when it attempts to access this, it doesn't exist. There's nothing here. Okay, and so we now have a problem, error. And so we run into an index out of bounds problem, out of range. You're trying to access something that does not exist. So when do we need this thing to stop? when do we need it? When do we need it to stop? Well, the furthest index that we're ever trying to access, the deepest index, the latest index that we're ever trying to access is this. I plus 3 is always going to be the biggest index we're trying to access because we're using I as our base. I plus 3 is what we're always going to try to access. So I plus 3, when we're accessing, let's say I is 1. So if I is here, the furthest that it's going to try to ever access is the 5 right here. Okay, so I plus 1, 2, 3. So that means we need to stop. Okay, we need to stop when I is here, which is always going to be, okay, this is always going to be this many spots from the end. So the length of this is 1, 2, 3, 4, 5. Okay, the length of this is 5. We need to stop this when I is 2 or when I is 1. So in this case, I is 1. That is the last place that we want this to be. And so we can simply do some subtraction here. And we can say, hey, you don't need to run this for any longer than when I is 1 in this case, but 4 less. So let's do length. If the length is 5, we want to stop this at the length of this, whatever the length is, minus 3. Okay, we want to subtract 3. So this index is 4. We want to subtract 3. We want to subtract 1, 2, 3. Okay, so we're gonna do length minus 3. And so in our input, instead of doing length minus 1 to get the last index, we are gonna stop this at the length of the input minus 3. It's always gonna be a minus 3 no matter how long this is, because we are, because plus 3 is gonna be the farthest thing that we're trying to access. We need to just simply subtract that, and that's where the I needs to stop. Okay, so this will put us back in bounds. And when I run it, I get 1543. Let me see if this is right. And that is the right answer. We now have a gold star. Very, very helpful. Okay, so a lot of information here. But this is the part that we care about. Really just these two things. The function for part 1 and the function for part 2. We used basic tools. We used variables, okay, to start to track our information as the program moves along. Remember, variables, they're called variables because they can change. Okay, so we can assign new values to them. So we're using that to count up, to track the number of times we have an increase. We're using a for loop to iterate through a collection. This is something that you always have to do. So understanding this is key. We're using a for loop to iterate through a collection. For loops are cool. And the first part of the for loop, understanding the parts of a for loop is very, very important as well. The first thing that happens is we set up our incrementer here. This is going to execute once. When the loop starts, it's only going to run once. Then we set the parameters for which this loop should run. We set the conditions in which this loop should run. So the loop will run as long as this statement in here evaluates to true. This loop will run. And then after it runs all the code that's inside of the curly braces, it'll execute this last part here. We did I++. It could be anything. Whatever's in this last spot will execute at the end of every single run of your loop. And yeah, so we set up this for loop, and we're using this index here. We're using this number here as an index to be able to access each item inside of the list and go through them one by one. To access one, to do something to it, to add one at the very end, which offsets I by 1, and now that moves over to the next index item. And we do the same thing for both of these. We just had to do a slightly different implementation when we were attempting to do the sliding scale. That's part 2. Okay, so really quick, we're gonna take what we did here and we're gonna turn it into JavaScript. Let's just do it with JS because I've been writing JavaScript recently. So we'll just do it there, so I'm not having to remember Python or something else, some other language, Ruby, whatever we want to do it in. But let's do the same things in JavaScript. This is less about converting what we did into JavaScript, but rather implementing the same sections that we did, solving the same problems using JavaScript, so that you can see that it doesn't really matter which language we do this in, that they are very, very similar in what they look like. So let's create a new file. Let's add a node and let's call this day1.js. And for this one, I'll actually show you how to do it with pasting in the output instead of, bringing in a file and reading that file line by line. Let me show you what it would look like if we were to kind of just copy and paste our input here. So let's create a variable called input. So let's const input, and we're gonna set that equal to. So JavaScript, you cannot create, again, a multi-line string like this. So we got to do like a little template literal here. And we're gonna use a backtick here. And so I'm going to go into our input. Whoops, let's grab it again. And I'm gonna paste it here. All right. Okay, so now we have 2,000 lines right up front for our input, but our input is just one giant template literal. It's one big string, kind of the same way it was in Go, but we were reading line by line to do this. So how can we get our input into a format that is meaningful? And I'll go back up to what we were trying to do with this. Is we're on number 2 here, getting our input into a format that we can use. So the same thing that we did over here in Go, by getting this into an array. We did all this input parsing function to get it into array. I'm going to write a little function to do the same thing. So function, function, and I'll call it the exact same thing, input parse. All right, input parse, because we're not we don't need a file. We just need a variable, which is input. We'll call it, that's gonna be confusing. Well, input list. Okay, we're gonna have our input string. It's a string, so I'm gonna call it input string here. In JavaScript, we don't have to set what our output's gonna be if we're returning anything. So we're gonna pass in this list right here, which again is a string. When you get a string like this, there are a couple of cool methods that JavaScript has that make this easy. Here's the problem. Here's why we're using Go and not something like JavaScript. Well, I guess this is the same in both languages, but knowing that, like, you've got to learn what methods and things are available to you. These are still core parts of each of the languages, but a lot of it comes down to what you're familiar with and getting familiar with the tools that you have available to you. But what we can do is there is a method, a commonly used method in JavaScript called split. And what it'll allow us to do is to take a string. A split allows you to take a string and to split it up into individual elements in an array, actually. So it'll take the string, it takes in a string, it returns to you an array of strings that are split up by a delimiter that you specify. So you set a character to split this thing up on. So I can actually split this thing up because each line is a new thing. I can split this up by line here. So the way I can do that is because lines actually have a character. So I can do, let me see if I can remember the syntax for this, but I'm gonna say split input is equal to input string. So input string is the string that's being passed in. It's gonna be this entire list right here. And this method that we can use is .split. And what goes inside of the parentheses here, this split function, the split method, takes in the character that you want to split on. The character that we want to split on is the new line character. This is a new line character. You don't see it here, but it is there, okay? So we're gonna split on that. which should give us it should give us an array or a list of each of these things as a string. So just to be sure, I'm gonna console.log this. I'm gonna console.log split input. All right, to make sure that we got what we needed here. And I'm gonna run it. I should have done that. Let's open that back up. And what I'll do, I have to remember this. My muscle memory is gonna stop me from doing this. I'll just put this in the background and I will go, node, what do we call this? day1.js. And when I run it, nothing happens. Let's go back into it and see why nothing happens. The reason why nothing happened, the reason why there was no output is because we created a function, and functions only run when they're called. So I got to go down here and I have to actually call the function. So I'm going to call input parse, and I'm going to pass in our input. Okay. I did it again. Told you my muscle memory is not going to allow me to do this effectively every single time. And dot split is not a function. So it's input. Is input string not a? Hold on, I'm gonna have to look up what that is. Dot split is it lowercase? Maybe it's lowercase. You know, it's okay to just guess out here sometimes. It's okay. Let's run it again. Okay, that works. It was lowercase, not uppercase. And what I get is an array with each of these items, and they're strings. Notice that there are quotations around them. They are strings. And there's, it says it has 1900 more items. So it only showed me 100 of the items. But we did actually get out an array of what we wanted. So now we can work with it in the exact same way. So what I can do, I don't want this to be a string though. I want these to be numbers. So what I can do here is, I can write another loop really quick. I can say for JavaScript, we probably don't even need to do that. Yeah, we can actually do this during the comparison. Let's get it in the exact same format. So what I'm gonna do is I'm gonna loop through everything. So I'm gonna loop through every item. I can use the same for loop that we use over here in Go as a, if I'm unsure of how to do it, I can look at it and I can do the exact same thing. And I can say, hey, I'm gonna iterate over every item in this list. So while I equals 0, while I is less than the length. Actually, I think in JavaScript it's dot length. So I'll do split input because that is our array. I think is that how you do it in JavaScript? We'll find out in a second. And at the very end of each of those, I'm going to do an I++ here. All right. And what I'm going to do is I am going to create a new variable here. I'm going to call this input ints. Okay. And I'm going to set it equal to an empty array. So this is going to be an array that holds the integers instead of the strings. So we're going to take the strings. So we're going to convert. First, we're going to split up this string into an array of smaller strings. Then we're going to iterate through all that array of strings, and we're going to convert them all to integers, and we're going to push them into a new array. So I think I can simply do input ints dot push, the dot push method, I think. So input ints is the array that I want to push into. Dot push, the thing that I want to push into is split int, split input I. So as we're iterating through, we're going to iterate through each item in split input, and I want to push that into the new array, but not necessarily just, so if I just push that into the new array, that'll just give me two arrays with the exact same information in it. I need to do a little bit of math. And I think there's two different ways you can do this. I think I can convert this with the number function. or I can parse int as well. And let's try that. Let's try that. And what I'll do now is I will console.log input ints. So this should give us a brand new completed array that only has integers in it rather than strings. And let's do that again. And notice how our output now, before it was strings, now it is integers. And we know because it does not have quotations around it. So that gives us a good indication of what they are. So now we've written an input function that kind of gets us to the same place as our input function over here in Go. Okay. They do the same thing. We essentially take in some information and it basically returns us an array that we can start to use to write our code. Okay. So now that we're in the same place, let's actually do our problem solving from part 1 and part 2. Okay. So here's the code for part 1. Let's do the exact same code over here. So we'll do function and we'll call it the same thing. We'll call it func part 1. It takes in some input. Okay. And I'll say, yeah, it takes in our input array. Yeah, let's do that input. Let's call it input array. So we're very explicit about it since we don't know what data type it is. It takes it in. And let's do exactly what we did here. We set up a variable called count. We set up a variable called, oh no, this is this one. So we just set up a variable called count here, and then we set up a for loop. So let's do it again. For let I equals 0. While I is less than the input, the length of the input. So input array dot length minus 1 I plus plus. So the exact same logic that we have for our Go code. What happened there? All right. So all we're doing is we're doing another if statement, and we're gonna say if input array at the I index, if that is less than input array at the I index plus 1, then go ahead and add 1 to our count. Same exact thing. Look how similar this code looks. 2 different languages. Our code is essentially the same. Look at, we got a couple things in here, but look at this. The only difference between this code and this code is some parentheses. That's the only difference here. Okay, it's in parentheses, so you can see how we're using different languages. The same things apply. These core fundamentals still apply. So we did that here. Let me delete this line because I don't think we needed that one. We closed the for loop here. And what are we going to do? We are going to simply return count from our function, and this should close that. I'm definitely missing something here. Let's see what I'm missing. Oh, I didn't close this. All right. So part 1, I think is going to work. So we need to do our input parse. So I'm going to get some new input here. So I'm going to say parsed input equals this. So first it's going to parse the input that's coming in. It's going to get it into a good format for us and give us an array that we can work with. Once we have that array, I'm going to go ahead and pass that array to part 1. So I'm going to do console.log, and I'm going to call the part 1 function. I'm going to call it with the parsed int passed in. The parsed input, sorry. The parsed input passed in. And this should give us output for the first problem. So I'm going to save it and I'm going to run it. Unexpected identifier. I have an extra character on line 2016. So let me fix that. There we go. That was just an errant character. Save it. Run again. Array.length. So that length is not how. Is that not how you do it? Reading that length. It must be. No. We did it up here. Let's see. See what our error was. Properties of undefined for input array on line 2015. Specifically this one. So that length is how you do it. We have part one as the input array. It's saying input array. Parsed input gets passed in for y is less than input array dot length minus 1. Let's see. Can I read properties of undefined? What are we missing here? Split input dot length. One. Takes in parsed input. Oh, okay. All right. There we go. So I'm not gonna chop this up at all. The issue is that we are console.logging this up here instead of returning it. So there's actually nothing coming back from this function. All right, there we go. That should fix our problem here. And let's go ahead and run it again. Not a number, close. So return input ints. Count plus plus. What if we equals 0? Let's be explicit there that this is an integer, and there we go. We made it an integer and we got 1521. Was it the same thing for go run? Yeah, so 1521, we did get the right answer for the first problem. Excellent. So let's take a look at it. And we did the same exact thing for part one. We iterated through and we compared the two values, compared the current item, current element in the list to the next element, and we added one to count each time. Excellent. So now let's go ahead and do the second part, which is essentially the same thing. So I'm gonna copy this. And I'm gonna do the same thing that we did in the other one. Part two. We're still taking input array. We're gonna let count, but we're gonna have two other options here now. We created a variable called sum1, and we'll set that equal to 0, and we'll let sum2 set that equal to 0 as well. We're still gonna loop through in the same way, but what we need to do is implement this portion here. We're adding two things together. What's exciting about this is we can literally copy this code. Super duper helpful. Oh, no. What just happened here? Undo. Redo. Okay, there we go. Sorry, I messed up there. I can literally copy this code as is. This works. One language to another. Okay, so I can take my sums here and I can put my if statements. Look at this. This is exactly the same. It looks exactly the same. Two different languages. Super nice. Return count. All right, and so instead of input array I here, we simply are going to do sum1, and we are going to do sum2. And hopefully this will give us the same answer. We didn't actually call our function now. So let's go down to the bottom and let's take this and let's call part 2. And now when we run it, we get 1521 and 1109. We did something wrong here. It's supposed to be 1543. Let's look at it again and see what we did incorrect here. If someone is less than sum2, count, return count. Oh, we didn't change this, but that actually shouldn't be a problem. Input array to length -3. We're still doing the exact same sums here. Sum1, sum2. Let's see if we get the right answer. 1108. Interesting. Let's see what our problem is. Why are we getting 1108 instead of 1543? All right, we got another problem. We are taking an input array. We have count, sum1, sum2. We're letting sum1 equal, those 3 items, which should be numbers, which we know they are numbers. Sum2, if sum1 no. If sum1 is less than sum2, count plus. That looks good. All right, that looks really good. And then we are returning count. We might have to put in some probing statements here to see. Let's see. Let's do a console.log here. Let's make sure we're dealing with the right numbers. Let's do 1 plus sum2 equals not someone. Someone versus sum2. That's a weird probing statement. So I can just see what they are, and maybe down here we can do something like this. Console.log adding adding 1 to count and give me a value of count. Maybe something like this is more helpful. Let's go up and delete this, and let's see if everything is happening correctly here, even though we know it's not happening correctly. One that wasn't helpful because we didn't see how many things were I want to count. Oh, no, I'm printing out before I add. That's fine. So this should be 1 less than the value that we're getting back. Makes sense. Let's see. Well, I is less than the length -3. So 1 is I plus 1, I plus 2. It's 1, I plus 2, I plus 3. Huh. Oh, I wonder. Pass back. Ants. I was wondering if I was modifying something here. let's actually make sure we're doing the exact same thing. So count, sum, 2, 2. I is 0, 0. The length of this minus 3. So maybe let's check that really quick. Let's do a console.log on input array.length minus 3, which should give us 1996, I think, something like that. Let's make sure that we're, getting something like that. $1997. Okay, 1997. That's good. And this is giving us 1108. Let's see then. So it's running for the right amount of times. Helpful. 4. Same thing. I++. The end. Just doing sum. We are setting the value to those indexes, sum 2, if sum 1 is less than sum 2, count ++. Interesting. I don't know where this is going wrong, but that's okay. Let's figure this out here. Sum 1 0, sum 2 equals 0. Iterate through them. So 1 plus input I+2. So I'm making sure those are correct. They look correct to me. Sum 2. So returning to count ++. This feels correct. Oh, no. Returning count. That should be fine. But let me just, this might be no, that's fine. Because then it would be more, not less, if that was the problem. And I don't know. That's interesting. This is the exact same code. Oh my gosh. I lied. Whoops. Sorry, I lied after a bit of troubleshooting. It is not the exact same code. I could just change my input to be this, but it needs to be input array. I was like, oh, what's going on here? Simple problems here. Input array, input array, input array. All right. Now it is the exact same code. Sorry about that. Now it's the exact same code. And so we can save it. And now we can actually run it and we get 1543 as we are supposed to get. Let's remove that console log every time. And we can now see both of these answers. And we can see that that's the exact same thing as if we were to run our Go code. $15.21, $15.43, and our code is pretty darn similar, if not exactly the same, especially for our part 1 functions and our part 2 functions. So that's how we do it with JavaScript. Very, very similar. If If you enjoyed this content, please give this video a thumbs up. If you want to see more, please consider subscribing. You can also head over to our Twitch channel where we offer completely free boot camps in computer science and software engineering, DevOps and site reliability engineering concepts, as well as cloud computing. We also have a lead on a number of engineering roles. So if you're interested in any of those, shoot your resume over to resumes@mastermind.io, and we'd love to get you connected to companies who would love to have you.